we move to our next important topic, which is MapReduce. So today in our hands-on, we are going to look at a couple of things. So how to write a basic program and how to run it, how to basically, let's say, aggregate data, how to perform some kind of joins, and so on, so forth. Now, before that, let's kind of understand the architecture of how you deploy them so that we are very, very clear with this. So pay attention. Yeah. So let's go ahead and do everything. Okay. So that the flow remains. So let's first talk of the same diagram here. Oh, I have Mac. Okay. I have CentOS. It has Unix file system. I have Hadoop file system. We already saw HDFS commands. Now it's time to run MapReduce. So let's first understand the deployment architecture. So on my CentOS, I will write this great code which is called MapReduce code. And oh, that code is written in Java. So I have code that. Good. When I submit this code, okay, it will get registered with the resource manager. So I'll be able to see on resource manager that. So leave the code part. Let's first understand the deployment. You write code on your CentOS machine. Write it. After you write it, when you submit, it goes to resource manager. Resource manager internally will call app master and say, okay, boss, do the job. App master will do the job. And after the job is done, the job will be archived at job history server. So don't worry about code. Don't worry about MapReduce program. First, let's worry about the deployment part so that we are clear with what is the flow. Writing code is easier part. Understanding the flow is pretty important. So without worrying about what I'm doing, let's submit one MapReduce program first. We will understand the deployment architecture. So we'll go step by step. Right now, you have to look at from a perspective that how will it get deployed on the cluster? Okay. So first, in HDFS, I have created a directory called word count input. I will first delete it in front of you. HDFS DFS ls or Hadoop FSLS, whatever you want to run. So there is a folder called input and there is a folder called output and apple and aggregation and aggregation out. I will delete everything in front of you so that we are very, very clear. HDFS DFS rm-r user training star. So please delete everything that is there. So it has deleted. So right now my user training directory is completely empty. And now look at it from a perspective of how it is deploying on the cluster. Don't worry about the code. We have whole day to look at the code and that's an easy part. Okay. So let's first create some sample data. So I'll say vi, okay, intellipat.txt. I'll say Intellipat is one of the very first companies who got into big data. So I've actually created multiple lines, okay, who got into big data. So they have a big data COE. They are good at big data. They are very good at big data. Let's just say I'm putting something. The idea is that just mark your words that I have used big and data 4 times. So that means big is 4 times and data is 4 times. Okay, because we will run some kind of word count job. So this is my input data. You are free to put whatever you want. So this is in my Linux box. I want to put that into my Hadoop. So first what I'll do is HDFS DFS mkdir, and I will create a folder which will be called as input. So I'm creating a folder called as input. Life is good. Then I say HDFS DFS. You can use HDFS DFS or Hadoop FS. Don't worry about it. It's the same command only. Okay. So call it biscuits or cookies. They are same only. Okay. So HDFS DFS put IntelliPad.txt in my input directory. So life is good. HDFS DFS ls input. So what I see is a file called as IntelliPad.txt. Okay. So now input is there. It's time to just run a code. So this is some ready-made code, word count.jar. I have written it for you. It's ready. Just leave it. It's fine. Right now we are not interested in how to write code. Hadoop jar word count.jar. The input folder I created is input, and the output that I will get is output. But right now my perspective is how does it get deployed on cluster. So we will see both of it. First, I will go to localhost and I will go to 8088. So this is my resource manager UI. Right now I have not submitted any job. This is simple. And this is my job history server. Okay. So let's just say, so this is my job history server. Okay, it's connecting. It's fine, it'll come up. Okay. So right now my job history server, this was my previous runs which are there. This is 0 applications. Resource manager has no applications. Now pay attention. I'm saying Hadoop jar word count.jar input output, and I say bang. Once I say bang, you see the job has got submitted and it has got accepted. We don't know the status because resource manager has just got it. Click on that and you see the job is still running. It is not complete. It is running. Let it run. It's doing something. We are seeing that. Let it run. But pay attention to the screen right now. Okay, there is a tracking URL which is application master. 24 seconds. Job is running. It is doing word count. That's easy. But look at it. The tracking URL changed to what? History. And it takes you to the job history server. It is taking you to the job history server. You can actually refresh it from here itself, and you will see that the job will get registered here. So the job was submitted, it ran successfully, and it will appear in the history. Okay, so this is the job that I ran in front of you. Now this job, okay, this is where I will see the time and everything. So this job ran, it would run certain mappers, certain reducers. This job ran one mapper, one reducer. I can see the logs for mapper and I can see logs for reducer. Okay, so now just to understand the flow, we will first reiterate the diagram again. So this is my task. I can see my logs and everything in that. So the UI is there, click on logs and you will see logs. And that's how you understand the flow of how the job is getting submitted. We will come to the code. It's important to understand the flow. So my job has run successfully. I say HDFS DFS ls. I see output directory. Life is good. Within output, I see two files, success and part R00. You know why success is required? Success is a 0-byte file, which is a flag. See, in enterprise, you use tools like Control M, Autosys, or your own automation. If you're using an automated tool, how will automated tool come to know whether this job was successful or not? It looks for a file called as success. So this is like a flag, whether this job was successful or not. And this part R00 is your output file. So there was one reducer, so it came up with one file. HDFS, DFS, cat. And I say paste. And carefully look at it. Data is 4 times and big is 4 times. So that's my output. So I have successfully run my job. Yes, we have not got into the code. We have time for that. Right now, it's important to understand the logic of. I wrote my map reduce code. It was bundled as a jar file. So for guys who are not, from Java background, just to give you information, jar file is nothing but think of it like an exe file for Java. Just think of it that way. This jar file was submitted to resource manager, and resource manager showed you on a URL, which was port 8088. And resource manager tells you, hey boss, yes, job is submitted and I'm running it. It's running, it's fine. After the job is done, resource manager says my job is over, and the job history server has the status. That is how your flow will work. So you code, you deploy, and you see the status. You see the status. That's how it works. Okay. Now it's time. Now the next question that will be asked is, hey man, how do I write my code, and how do I bundle my code? So two questions now which are pending to be answered now is, how do I write my code? That's the next question we'll take up. And how do I bundle my code? Simple stuff. So these are two important questions to be answered. Once we answer these two, we will see some more programs on MapReduce. That will be the agenda. So now I'm going to talk about a problem as to how do I write my code and how do I bundle my code. Think of MapReduce program as three different Java classes. So I'll map this in the code, okay? So the first class, the main class, is called as driver. So that's your ignition point. Think of it like the place where in the car you insert the key. That's where you drive the whole engine. The second file is mapper, that talks about what should be done with each record. And then there is third file, which is reducer, which says what should be done with each group or bucket. So for example, the student's example, what should be done with each student, and here what should be done with China, comma, let's say 11111, the whole bucket. So the driver you initialize, driver will call the mapper will write its output, automatically framework will take care of shuffle and sort, then the driver will call the reducer and you will get your output. So as a developer, you are supposed to code three things. You will code the driver, you will code the mapper, and you will code the reducer. How shuffle sort works, that's something you will not code, because that's what framework will take care. It is as simple as that. Now, if you have this diagram in mind, I will map this to the code. And it is that simple. Every MapReduce program, my friends, that you use will have these three classes: mapper, reducer, and driver. So don't worry about it. It is dead simple. You just have to relax out. There are three things to know. What should I put in driver? In driver, you will put a very simple thing. Oh, who's my mapper? Who's my reducer? What is the input data format, output data format? In mapper, you will write the logic saying what should I do with one record at a time. And in reducer, you will write the logic which will say what you should do with one group at a time. Okay. Now, if this is the logic, there you will see a lot of things in the code right now. With that, today what we will do is I will show you 4 code samples. How many code samples? 4 MapReduce programs. In every MapReduce program, you'll have a driver, you'll have a mapper, and you'll have a reducer. Now you can also have advanced things like chaining, where you say that driver can have 2 different mappers, and then they will call the reducer. All these complex workflows are possible. Okay, so it's like you can go on making it more and more complicated. But the good practice is keep it simple by having multiple MapReduce programs and call them as a workflow. So what I'm trying to say is, can I code like mapper, then reducer, then let's say one more reducer, for example? Yes, you can. But a good practice will be MapReduce, and then chain them as a workflow. That will make your code very, very maintainable. Okay. So let's look at, today we will look at 4 examples. So now we've understood how this works. We will now jump into the code. First thing we'll talk about is how to write a word count program. Okay, what we just did now. We will look at one more example, which is how to aggregate. Same thing, like word count is aggregation, this is also aggregation. We will then see how to do joins. So there'll be 2 type of joins we will see: joins in mapper and joins in reducer. These are the 4 code samples we will see. So let's go ahead and do that. Now it's time to basically look at one piece of code. Okay. So on LMS, let's say everything is available, you can download. Now just help me out. From LMS at download, there are, what you call Hadoop code files. So there is writing map reduce program, multiple input format, joining, how to aggregate data. These are some of the files. So I get word count and my code is in source. That's Java code. Let's talk of code. I open in gedit and the first thing you say is, no man, how will I in real world write it in Notepad? So you should not. You should actually use a tool called as Eclipse. So why don't we directly look at it in Eclipse? All you need to do is open your what you call this thing. So let's start from a fresh slate. So I open Eclipse. Eclipse is saying me that, Mr. Ravi, I will look for your code. I will look for your code in home training workspace. So you better have your code there, because that's where I'll point to. I go to my home training and workspace and I realize that there is nothing. There is some file called intellipad.txt. Let's get away from that also. So Eclipse is saying that, dude, I am expecting your code or new projects will be created at workspace. And in the background, I see workspace is completely empty. So we are starting with 0. Okay. I go to workspace. Okay. So how do I create a project right now? So one way is I can directly create a project from here and I can, build a file. I can do that also. Or I can take this project that we've got, okay, and take this word count project. So I'm just taking this and putting it inside workspace. Okay, so there are some additional files, ignore them right now. Okay, and I will simply say that I would want to create a new Java project. It says, where is the code? I'll say word count. And this guy says, yes, I realize there is word count. When I say finish, okay, so there are some files I see, but God, there are some errors also. So here you go. This is trainer's code. Looks to be pretty good. Problem is that there are so many errors. What do you do right now? The errors are because you have never got the libraries. So it's time to get the libraries. So let's look at it. There are good amount of errors. Let's say 48. Let's bring the library one by one. So we say Java build path, add external jars, user lib Hadoop, and get all the Hadoop libraries. Once you come in, some errors will reduce. So there are actually less errors right now. Now we need to get libraries from map reduce also. Add external jars, lib map reduce. Perfect. So some errors are less. Let's see what is the error that is still there. There is something called generic options parser that appears to be a pain. Now let's see what you are supposed to do. First thing, you've got map reduce, but you are supposed to deploy your code on yarn. So you should also have the yarn libraries, and you should also have Hadoop lib and these libraries. So I've created all the libraries, and so good, all errors are gone. We are happy, pretty happy. Errors are gone. So let's say code is given to you. We've not got into code, but you imported the library and it is code free, right? It's like error free right now. So let's say export. So I'm showing you how to bundle it now. First, we'll jump into code later. I say jar, and I'll say put it in home training word count.jar. I say finish. It says there are some issues. I'll say okay, ignore them. So I see this jar called as word count.jar. This is just now created by me. This is just now created by me. Let's run this. Hadoop jar word count.jar. Now my package is com.hadoop.wordCount. com.hadoop.wordCount. Okay. I am running it with input data, and I'm running with a new folder called as, or let's run with output, but we should clear the output. So hdfs dfs ls. I will delete the output folder. hdfs dfs rm-r output. So I've deleted output. So let's run this job. It says it was expecting output folder. I said no problem, take it. So the job has got submitted. So once this job succeeds, you know how to see output. And we'll pause for a minute to document the steps for you so that you see that this pointers will be there for you to see. Okay. So let's first talk about how to create the code. So first one, take the code from LMS, unzip it, take the word count folder and put it in workspace. Open Eclipse. Good. Say new Java project. Include libraries from user lib Hadoop, user lib Hadoop lib, Hadoop Map Reduce, Hadoop. Yeah. Export the code as jar file. Run the jar file. Bang. You are done. Okay. So how to create a code? This is option 1. This is option 1. There is other way also. We'll see that. We will see that. So then this is your option 1. Okay. Now option 2. Option 2. So this is called using Eclipse. So using Eclipse. Option 2 is using a build tool called Ant. Let's see what do we mean with that. Let's see what do we mean with that. Okay, so we will do this and then we will jump into the code. So we'll pause for questions and then we'll jump into the code. Now, I don't want to use Eclipse. No, I'm not comfortable with that. You know, I am a guy who's, let's say, very comfortable with build tools. So don't worry, IntelliPat has already taken care of that. In the word count folder, okay, this code is ready. I'm supposed to build a jar file, but jar is already there. Let's remove, we'll see it. So you use a tool called as Ant. Ant is a tool that will create a jar file based on the steps. Let's look at it. It will be simple. Okay. Just to prove that I am doing it differently, I will do completely different setup here. So let's look at it carefully. I'm saying mkdir America. This directory is nowhere I have created in front of you. Then I say cp Hadoop code files, writing map reduce program, word count. I want to copy this entire folder in America folder. So I'm not using Eclipse anymore, okay? I'm copying it in America. It's done. Look at it. lsltr America. You see a folder called as word count. Now I say cd America lsltr word count. What man, this jar file is already ready for me. So I will delete this jar file in front of you. I'll say rm-r word count of jar. So now you see there is no jar file. So Ant is a utility that you install and just go to word count folder and run this command Ant. And Ant has successfully built a jar file for me. So this was like from the command line. Now what I do is, it is simple. I'll say I want to run this word count.jar. I'm directly running word count.jar, which we created right now. But instead of output, I'll give another folder Ant. So output came, just to prove HDFS DFS LS. I'll see how it's going. So let's document. If you want to use a build tool, first in your VM, just run a command. First, install Ant. Use a command sudo yum install Ant. Copy word count folder from the LMS code files to say a new location of your choice. We did it in America. Now there, just do cd word count and delete existing jar. Run Ant command. Bang, your jar is ready. Run your code. Now Eclipse is very easy, you know, it's all automated. But now the question would be that, can I have this Ant based stuffs? I have already given you all the steps, But if you want more details, each program has a README file for deployment. So if you go to this Hadoop code files in word count, there is a proper readme.txt that will tell you how to do it. Make sure your folder paths are correct. That is something you can take care of. This explains you the logic of the program, and at the very end it tells you how to run it also. It tells you that exact steps also. Okay, so this is readme. If you're doing from Eclipse, that is easy, just import a project that you don't need a documentation. But if you're doing it from the background, this is what you should be doing. So I've documented both the steps. So at least one thing is clear. At this moment, we are clear with how code gets submitted, how code gets bundled from Eclipse, as well as from command line using AND.